in our daily, I guess there's daily life here, but it's the second result. Okay, I'm gonna do it. Pulling the trigger. 3, 2, 1. Okay. That was fun, I guess. The tweet dragged on way too long. That honestly could have been a YouTube. Oh, I have to upload it to the GitHub. Also, you have to like it. So if I go to Manim tweets, not there. And then I can copy this. And this is like 2021. What's the date? 3/24. Let's say lenses. How do you feel about this tweet in comparison to the others? That's a good question. I feel like this one's a little long, which isn't that great for a tweet. The insight it draws is really good. I really like the connection between this, like AP Physics, to your eyes. I think that connection is really interesting to draw attention to. There's just a lot of stuff that was really hard to represent. Like the eye diagram was just a ton of code. It didn't really just, oh, whoops. Just because there's so many parts to it. And then like adjusting the lens and things like that was also just way harder than I expected it to be. I would rate this like a 7 out of 10 tweet. Yeah, it isn't just a pretty picture. Like this is totally just because it's eye-catching. This, less so, but yeah, this is sort of a mix of both. I think this is a good one. This one was also really good. I think it was pretty good, yeah. Is it a good thing or a bad thing? I think it's a good thing in this context because we had a few of them in a row that were just nice to look at. I think teaching something is good. It's sort of like this one, but more of a physics angle to it. We really need to get our colors together because right now, like even for this, I had to edit these colors. These aren't the original community colors. It's just harder to use the community colors. And so we end up not using them. Okay. Okay, lenses.py. We add that. Also more vivid. Yeah, especially when you choose them right, they need a little tweaking. Like these colors were chosen randomly, basically. But if you put them into a tool that was built for color theory, you can come out something with something that's a little bit more like mathematically harmonious. Okay. I'm gonna call this add lens tweet. Pull. Okay, then I'm gonna push that. Oh, that didn't work. Oh, it's main. Okay. That was an experience. Okay. That was an experience. Now I get to work on my shader code, which I'm both excited and not excited to work on at the same time. Should be in shader.py. Okay, so here's the... Wait, and I'll go to the renderer too. The deal with this is that I wrote this shader. Well, no, I mostly wrote it myself. This shader for rendering quadratic Bezier curves. And then I'm hooking into render in the OpenGL renderer to just render a quadratic Bezier curve. And then in the shader, I'm hard coding this data to go into the shader. The shader looks like this. And this. A lot of that was copied, just like copied online. Now, when I render this, I get a line. But what's important is that this line can actually be any quadratic Bezier curve with a few stipulations. For example, if I change the P0, P1, and P2 points from these, which is a straight line, to -1, -1, 0, 1, and 1, -1. Oh, wait. And I add dots that are just going to outline a unit square. Then you can see that this is drawing a Bezier curve between these 2 points in the unit box, which is great. I found a way to draw a Bezier curve. The problem is that you have to pass in addition to these control points, you have to pass in the coordinates of this surrounding triangle. And it doesn't have to be red like that. Like, what I'm going to end up doing is just throwing out that pixel if it falls outside of the Bezier curve. And so it'll look like that. It won't always have that triangle. There's a difference between quadratic and cubic Beziers. Yes, a lot of a difference. When you get into things like... So the problem is Bezier curves are really strange curves. Like, they're not inherently polynomial or anything. They're just defined. I'm going to switch off that account so I don't mess anything up. They're defined in such a strange way that when you try to do things like compute the distance to them or compute offset curves especially, the math gets pretty complicated really fast. And there are a lot of instances where quadratic Bezier curves can be solved, but cubic Bezier curves are either much more difficult to solve or just can't be solved analytically. And so that's the difference from a graphics perspective. Also, if you're doing like a lot of math with them, that could get tricky too. But regarding this, the main problem to solve right now is the following. Okay, so this is the problem. I'm drawing this Bezier curve. And to do it, for each of these pixels. Okay, so this is the problem. I'm drawing this Bezier curve. And to do it, for each of these pixels, I'm computing the distance to the actual Bezier curve. And if that distance is small enough, I'm making that point white. However, if I made this just like super, super thick, like instead of 0.07 here, I did like 1, the curve will get cut. Well, that's just like insanely big, but if I did something like this, the curve will get cut off by the triangle. So the question is, given the Bezier curve from its control points, how can I find the coordinates of a triangle large enough to surround it completely? And I think this ends up being kind of an annoying problem. Or maybe I'm just not looking at it correctly. But I essentially have these 3 points. And I have this thickness. Well, these make a triangle. But I can't just use these 3, or else they'll get cut off. I need to, knowing the thickness of the line, expand this triangle. So probably expand that side, that side, that side, and get like these expanded points where this will probably be expanded from the center of mass. So you can call that like M. You're going to want to expand these out. Such that this distance, which I know is long enough. And the question is, if this is like point A, and this is point A scaled, so I'll say S times point A, right? Maybe S times point A isn't right. Because A is a vector. Yeah, A is a vector. So this is like S times the vector A minus M. And then I have to find S. And this is going to be some geometry. Because what I could end up doing is just making the triangle enormous. That would actually work. Like in this case, I'm just doubling them all. But that won't work in general. And actually, this isn't even always possible, because if these points lie on a straight line, I have to find a different sort of geometric solution to surround them. Probably by using like 2 triangles to make a rectangle. But I can deal with that later. So what I think I'll have to do, what I'll have to do is I'll have to find S such that, let me take notes on this. We'll call this like triangle problem. Oh, that shouldn't be dot pi though. Also, if you get an answer to this, if you happen to know vector algebra, that would be super helpful. So anyway, I have to find S, the scaling factor, such that how much vector algebra do you know? What I'll probably end up doing, I'm probably going to end up just putting this question in the Discord, and someone will totally solve it, right? Someone will just solve it. Just putting this question in the Discord, and someone will totally solve it, right? Someone will just solve it, and then I'll just use that. So here's what it'll be. I have to find this line. Okay. You'd have better luck in the server. Yeah, that's fine. The distance between... Okay, I have to name this point too. Let me just call this one B. So that this vector pointing towards A, that one is A minus B. You want to find S such that the distance, so that'll be the norm of M. Oh man, so distance from M, the midpoint, to this line, which is B plus A minus B times X. And this is the scaled one, since this will be S. This is A minus M, this is B minus M. The difference between the distance from M to the scaled line, this line. So this is S times B minus M plus X times SA S A minus M minus B minus M. A minus M minus B minus M, parentheses. The distance from M to this line, SB minus M plus X times this, which that could be simplified. And the distance from M to B plus A minus BX is equal to 2D. And so the question is, well, for one thing, how do you even get the distance from M to like this line? How do you get that distance? Does this have a magnifying glass? That's too much. Fuck. How do you... I don't know how to zoom out. Oh. Are these the only magnifications? Control plus. That does it in the browser. There's like a way to do it in like within this app. But this is good enough. But essentially, I'll have M, which is the average of these three. And what's the distance from M to this line? or the shortest distance from M to this line. And I think the way to do that is to project the vector. Wait. Yeah, I have to... Well, this is a... Or this is representing a point, so I don't think projecting this vector will help. But I have to take MB, this vector, and then project it onto... Wait. M minus B. Project it onto A. np.tile like this. 3, 1. Okay. And then I can say v equals np.array 1, 2, 3. Then I can have np.tile v 3, 1. Okay. Nice. So I want to do here np.tile this 3, 1. And then for these, I'll just do something very similar. So that, and then that. This shouldn't change anything, I think. But it did. Oh, I have to add a ones to it. Can I just do like cat or something like that? But basically I have to add an ending 1 to each of these 3 arrays. So I think I can just H stack this and then 1, maybe? np.array 1. np.array... I guess it'll have to be np.ones. And the shape will be... Um, 1 by 3. That's a 3 by 1. Okay, that's what I have to do. So an H stack of the tile, and then np.ones. H stack of that. And then... Wait, where does the... Oh, this should be one of these here, and then np.ones. 3, 1. I'd have to do that for all of them, I think. So that's for P0, here's for P1. And then for P2, here. And now, with luck, and there's something else wrong. Dispatcher takes 1 argument, but 2 are given. It must be this np.tile. Was this supposed to just take... It takes the array and then a tuple, right? Yeah, that's right. I feel like I have to back up and do this from the start. Let's just get this to where it's working again. All right, so there's my picture. And then here, what if instead of this, I just put the 1s here initially? And then I don't worry about the H stack. I just do np.tile, Bezier control points at 0, 4 comma 1, and that's it. So I'll try it just for that one. And that didn't even work. Cannot broadcast input array from 4.4 into 3.4. Wait, that actually makes sense. 4 comma 1. Should this be 3 comma 1 still? Since it's only specifying the number of copies? Okay, makes sense. 4 comma 1. Should this be 3 comma 1 still? Since it's only specifying the number of copies? Okay. Okay. So now that I've done that, I should be able to do this for the other ones. So for the first point and the second point, we can do this, remove those. Great. And honestly, I think I'm fine with just keeping it there for now and try to get into some of this geometry. So to start with this, you can say the midpoint. Oh, actually, it would be better to get rid of that one so that I can do the midpoint just by summing these. So I got to figure out the second input to this. So let me take out this one and try this again. This is going to be np.hstack of this together with np.ones. Then I think this is going to go rows and then columns. So 3 and then 1. So I'm going to have that for the first one, and the other two I'm going to just write out. Okay, so see if that works. And the same thing, the VHStack dispatcher takes one positional argument. What does it mean? Am I just this bad at NumPy? Here I have the HStack of... Oh, this is within a tuple. So I have to put these in a tuple? Nice. Okay, so that's all I had to do. And then this will make this way easier to specify. Oh, I have to remove the ones. Nope, something else broke. Did I put the tuple there? I did. Oh, I have to increment this. So at 1, and then at 2. Nice. So now I can try to actually do some of this geometry work. So let me just bring over that diagram from before. So M, control point average. I guess midpoint isn't right either. It's going to be something like np.sum, Bezier control points, and then axis equals 0. I'm just going to print that. Okay, so 0, -1, 0. That makes sense. Now that I have that, I'm going to try to get b minus a, which all of these points are symmetric. I'm going to get that vector and project it, or rather, m minus b, and project that onto a minus b. So I'm going to say, what should I even call this? I guess I'll just call it vector to midpoint. So say vector to midpoint equals, I'm just going to do the first one right now. Bezier control points at 0.